The closest potentially habitable planet beyond our solar system has fascinated astronomers for years. Orbiting the small red dwarf star Proxima Centauri, just over 4 light-years from Earth, Proxima Centauri b represents one of humanity's best opportunities to study an alien world without leaving our cosmic neighborhood. For decades, scientists could only estimate what this distant planet might look like. Everything changed with the arrival of the James Webb Space Telescope. Designed to observe the universe in infrared light, Webb can study the atmospheres of distant worlds with unprecedented sensitivity. Instead of simply detecting planets, it helps scientists investigate their temperatures, chemical composition, and the environments that may exist around them. Every new observation brings us one step closer to answering one of humanity's oldest questions. Could life exist beyond Earth? Recent studies of nearby exoplanets have revealed signals that continue to surprise astronomers. Tiny variations in infrared light, subtle temperature differences, and unexpected atmospheric signatures remind researchers that planets around other stars can be far more diverse than anyone once imagined. Among these fascinating targets, Proxima Centauri b stands out. The planet orbits inside the region often called the habitable zone, where temperatures could allow liquid water under the right conditions. However, living near a red dwarf star also presents enormous challenges. Proxima Centauri is highly active. Powerful stellar flares regularly erupt from its surface, releasing bursts of radiation capable of affecting nearby planets. Whether Proxima b has retained a thick atmosphere capable of protecting its surface remains one of astronomy's biggest unanswered questions. To investigate, scientists rely on spectroscopy. When light interacts with a planet's atmosphere, different gases leave unique fingerprints within the spectrum. By carefully analyzing these patterns, researchers can estimate whether molecules such as water vapor, carbon dioxide, methane, or oxygen may be present. No single gas proves life exists. Instead, astronomers search for combinations that are difficult to explain using ordinary geological processes alone. This careful approach helps prevent extraordinary conclusions based on incomplete evidence. Meanwhile, another area of research has attracted growing attention. Rather than searching only for biological signatures, some scientists also investigate technosignatures, possible indications of advanced technology. These could include unusually bright artificial illumination, powerful radio transmissions, laser signals, or atmospheric pollutants that are unlikely to form naturally. So far, none have been confirmed anywhere beyond Earth. Still, the possibility continues to inspire scientific investigation. Imagine a fictional scenario. Suppose future observations of Proxima Centauri b revealed a series of faint infrared variations repeating with remarkable consistency. At first, researchers might suspect instrumental effects or natural atmospheric changes. Independent observatories would repeat the measurements, carefully checking every possible source of error. If the signal persisted, scientists would begin testing increasingly complex natural explanations. Could volcanic activity create repeating thermal patterns? Could clouds moving through the atmosphere produce regular brightness changes? Might interactions between the planet's magnetic field and its active star generate unusual infrared emissions? Each hypothesis would require careful testing. Only after exhausting natural explanations would researchers even begin considering more extraordinary possibilities. That cautious process is exactly how science advances. The goal is never to prove sensational ideas. The goal is to eliminate ordinary explanations before exploring new ones. Whether Proxima b ultimately proves to be a lifeless rocky planet or a world with surprising complexity, it remains one of the most important destinations in modern astronomy. Every observation improves our understanding of planets orbiting nearby stars. And perhaps, somewhere within those distant measurements, lies the first clue that worlds beyond our own may be more remarkable than we ever imagined. The next generation of observations may bring answers. Or they may reveal even greater mysteries waiting among the stars. As observations of Proxima Centauri b continue, scientists are entering a new era of exoplanet research. Instead of asking only whether a planet exists, astronomers now want to understand what its environment is truly like. Is there an atmosphere? Could liquid water survive on its surface? Or is it a barren world constantly blasted by intense stellar radiation? These questions are difficult to answer because Proxima Centauri is a red dwarf star. Although much smaller than our Sun, it is remarkably active, frequently producing powerful flares that can dramatically affect nearby planets. If Proxima b has a strong magnetic field and a dense atmosphere, those natural defenses might protect its surface from much of this radiation. If not, conditions could be far harsher than scientists once hoped. To investigate, researchers combine observations from multiple telescopes. The James Webb Space Telescope studies infrared light, while powerful ground-based observatories measure tiny changes in brightness and analyze the planet's motion around its star. Together, these observations help scientists build increasingly detailed models of the distant world. Future observatories will improve this picture even further. The next generation of giant telescopes will be capable of examining nearby rocky planets with greater precision, searching for atmospheric gases and subtle temperature differences that today's instruments can barely detect. Every improvement brings astronomers closer to directly studying worlds that were once completely beyond our reach. Another exciting field of research focuses on technosignatures. Unlike biosignatures, which search for evidence of biology, technosignatures investigate whether advanced technology could leave detectable traces across interstellar distances. Scientists have proposed many possibilities. Powerful laser communications, artificial satellites, industrial chemicals in an atmosphere, or unusual patterns of light that cannot be explained by known natural processes. At present, no confirmed technosignatures have ever been detected. That remains an important scientific fact. Now imagine a fictional scenario. Suppose repeated observations of Proxima b revealed a faint infrared pattern that appeared only during certain orbital positions. The signal remained stable over many months and was independently recorded by several observatories. Researchers would first investigate every natural explanation. Could unusual cloud formations produce the effect? Could volcanic activity or geothermal hotspots explain the observations? Could interactions between the planet and its active star create temporary infrared variations? Only after years of careful analysis would scientists begin discussing more extraordinary possibilities. Even then, the evidence would need to be overwhelming before anyone claimed the signal represented intelligent activity. That level of caution has always been central to astronomy. History has shown that many mysterious observations eventually receive completely natural explanations once better data becomes available. Yet curiosity continues driving exploration. Every new telescope reveals details that previous generations could never observe. Worlds once known only as tiny points of light are slowly becoming real places with weather, atmospheres, temperatures, and geological activity. Proxima Centauri b is one of the closest opportunities humanity has to study another potentially Earth-sized planet. Whether it ultimately proves to be habitable or completely hostile, its scientific importance is enormous. One day, future observatories, or perhaps even interstellar probes, may reveal its surface in remarkable detail. Until then, astronomers will continue collecting data, refining models, and asking careful questions rather than rushing to dramatic conclusions. The search for life beyond Earth is not a single discovery. It is a journey built from thousands of observations, countless experiments, and decades of patient investigation. Perhaps the universe is filled with living worlds. Perhaps intelligent civilizations are extraordinarily rare. Or perhaps the greatest discoveries still lie just beyond the reach of today's technology. For now, Proxima Centauri b remains one of astronomy's greatest mysteries, a nearby world reminding us that even our closest stellar neighbor still has countless secrets waiting to be uncovered.